Good afternoon, everyone. I'm Krishna Kumar. I work for Microsemi Corporation, now acquired by Microchip. I'm responsible for product marketing for the Programmable Solutions business unit at Microsemi. So, to begin with, I'll give you a gist of what I'm going to be talking about. Some of it was covered by my friend a little bit earlier, but I'll talk a little bit more about it. I'm happy to see that there were a few questions related to Microsemi FPGAs. I'll be happy to answer them either here right after the session or afterwards as well. So I'd first be talking about the MiV ecosystem, what it is and what's part of that and what we're going to do further. Then the MiV Unleashed expansion board. And we also have a demo available at the demo area today. So it's a deep learning demo that we've worked out along with our partners Hi5 as well as ASIC design services. So I'll give a brief about that as well. I just have 15 minutes, so I'll try to be as quick as possible, but I will cover the most important points. You can, of course, reach out to me after this session. I'll be here tomorrow as well. Please do get in touch with me. I can answer any questions you might have. So the MiV ecosystem is Microsemi's initiative in working on the RISC-V portfolio, RISC-V architecture. So we are working with numerous partners, and we are developing a lot of it ourselves as well. And we are branding this the MiV embedded ecosystem. So it is to do with the RISC-V processor architecture, RISC-V instruction set architecture, and the tools and solutions and CPUs and softwares that come along with it. So we've been working with numerous partners. Some of them have already contributed. A lot of them we are still continuing to work with them. And you'll see in the next few slides what we've been doing so far. So to begin with, Microsemi is an FPGA organization. The business unit I come from is the Microsemi's FPGAs and SoCs. So we have come up with a bunch of soft CPUs, RISC-V-based soft CPUs that are available today to be ported on our FPGA portfolio. This is the range that you can see over here, different sizes, different capabilities. You should be aware from the part numbering. It's pretty much clear what is available in our portfolio. And this is an expanding list we are developing, and there's more to come. We also have an easy-to-use Eclipse-based IDE called the Soft Console, and along with our tools and evaluation boards. This is, for example, an evaluation board that comes preloaded with a RISC-V soft core in it. So we, along with our soft console development environment, you can write your own C code, and you can, if you're not interested in FPGA development and you want to work on C on a RISC-V microcontroller, then you can do just that with our system. And what's more is that this same tool chain is also available for ARM. So essentially, people who are familiar with ARM and would like to work with RISC-V, it's a no-brainer. It's an easy migration for you. You use the same tool chain, same hardware and software kits to develop a RISC-V-based application on our FPGAs. So we also have a firmware catalog. This essentially is a bunch of all our drivers that are supported along with our RISC-V soft CPUs. This is also available as part of our tool chain. And numerous Artosis we've been working on. So far what you see from our portfolio are soft CPUs. So these are microcontroller level cores. And we have been working with a bunch of Artosis all over the world. So some of them we've ported ourselves, and some of them are ported by these Artos vendors. So the open source, for example, free Artos was done by ourselves, and it's available from microsemi.com, and the commercial ones are available from our partners. So you can reach out to us if you have any particular needs on this. The details of this is available on our website. So we also have maintain a GitHub page where we maintain numerous examples. These are some of the examples that are available there. We've stored a lot more in our GitHub site. And all this we are doing essentially to kind of evangelize the RISC-V ISA. And the quicker we are able to do that, the more reach we are able to achieve, the better it's for every one of us. We do appreciate the advantages that RISC-V brings us, and a lot of it also will come because of how popular RISC-V becomes and how many people start using it. So these are our initiatives towards that goal. So as part of our MiV ecosystem, we also have a bunch of evaluation boards. These are some of them where you can port the soft RISC-V cores already available. These are our FPGA development boards. Starting from as low as $99, we have an FPGA board available for you to port your RISC-V and develop your applications. The interesting part, what my friend earlier mentioned, was that with an FPGA, you're not restricted to just the IPs that are available in a processor core. If you pick a RISC-V processor or a RISC-V microcontroller, you are pretty much limited by the features, the peripherals available in that microcontroller or processor. So when you work with an FPGA, there are a lot more that you can do. You can select the combination of IPs you would want in your application, and you can port that to the FPGA along with the RISC-V core, and you can write your own drivers and application onto that and make your own application system or SoC. So that's the big advantage of using an FPGA at this point of time, where you're still not sure what features you would need in a processor. And by the time we will have a lot more processors with multiple options of peripherals in it, FPGA is going to be the one that leads the market in terms of supporting features on RISC-V. So I would quickly take you through the Hi5 Unleashed kit. So this is Unleashed development platform. The Hi5 Unleashed kit was launched by our partners Hi5. And what we've been doing is we've partnered with them, and we try to come up with a development board, which is the Hi5 Expansion board. That's from Microsemi. And that works along with the Hi5's Unleashed kit. And together, what you get is a microprocessor subsystem from Hi5. Along with it, you get a powerful 300K logic element FPGA along with it. And together, you can pretty much develop any IPs, any system that you want to do. So I'll briefly cover about what we have in the Unleashed kit. So like you can see, this is another effort from Microsemi to evangelize RISC-V. So by coming up with this board, the Hi5 Expansion board, we are giving the opportunity or giving hardware platforms for hobbyists, for engineers, for customers all over the world who want to develop softwares, applications, drivers around RISC-V. They can do that with this solution. With an FPGA and a processor together, the sky is the limit as to what you can develop in them. So this is a snapshot of our Hi5 Unleashed Expansion board. So what you see here is the PolarFire FPGA, and we have the FMC connector. That's what plugs onto the Hi5's Unleashed kit. With the PolarFire FPGA, along with it comes a bunch of peripherals, the HDMI, USBs, and PCI Express connectors available, PCI switch and PCI Express, and more USBs and Ethernet and so on. These are the peripherals available along with this board. And this board actually comes, the FPGA comes preloaded with the chip-link and PCI root complex interface. So essentially, you could connect the Hi5 kit. This is a block diagram of the Hi5's Unleashed kit, which plugs onto the FMC connector over chip-link interface. So chip-link essentially provides a memory map interface. There was a question earlier about the interface. So chip-link provides a memory map interface between the FPGA and the Hi5's core. So what you get is the entire peripherals or the IPs that are built into here can be viewed as within the memory map in the RISC-V core. So together, so this is what this Unleashed platform looks like. This is the expansion board, and that's the Hi5's kit. In fact, we have a demo available in the demo room on this very kit. So yeah, that's actually a deep learning demo. That's what I'll talk about briefly right after this. So if you want to know more about this kit or our FPGA portfolio, reach out to me or visit microsemi.com. about this kit, there is data available on Microsemi's website as well as Hi5 website. Please do take a look. There was a question again about procuring this Hi5 expansion board. Yeah, so it was answered. I was kind of itching to answer it, but yeah, he answered it pretty much. So it is sold out on crowd supply. We are figuring out a way to restart one, but in any case, do reach out to me. My contact is right here. So please do reach out to me, or you can talk to me right after, and we can find a way to get a board to you. So a quick look at, this is deep learning is a demo that we've put up in our stall right outside. So I'll quickly cover this. I won't spend too much time. If you are interested, we can talk later. So any prediction model essentially would have a model, and once it's fed with some kind of input data, it makes some certain predictions. Essentially, that's what an inference model or a prediction model is all about. A deep learning model would involve a training algorithm that helps to train this model. And once the model is trained, it can make predictions much more accurately. So this is a better chart I like to explain this in. So what we have in our demo is a convolutional neural network that has been implemented on Microsemi's FPGA along with Hi5's U540 Unleashed kit that's available with us. We've ported a deep learning algorithm on our demo, and you can see that in our demo. So to begin with, how this would work is you would pick a readily available neural network, and you would train this with a lot of training set data. So essentially you will have, in this particular use case, it's a lot of pictures. It's pictures of different kinds of things that you would need this model to identify. So you would train it with a lot of pictures that are annotated. So in this example, I'm not sure if it's visible in the back, but this is a picture of a cat with the annotation that it is a cat. So these kind of data is fed to this model, and the model is capable of training its nodes, each of these nodes, and the values, the weights of each of these nodes, such that it is able to actually predict the image. So once you have enough amount of training data available, this becomes a trained model, in which would look like this, the size of each node indicating the weights of each of the nodes. Then a typical inference system which you would deploy in the field would look like this, where you just give a picture and it actually infers that it is in fact a cat. So there are a few reasons why we did this, why we've been working on this. So this is one typical example. I mean, not really typical, but it's one example where we've ported a deep learning algorithm on the FPGA, and we're working very closely with the Hi5 processor. Together, what you get is a system where this deep learning algorithm running on an FPGA is far, far more efficient than any microcontroller and processor, but all these features are readily available for the microprocessor subsystem based on RISC-V to do much more. So much more processing can be done on this trained model, and that's what our demo is all about. So there are some advantages of using Microsemi's FPGAs. So I'll quickly cover some of them. So a typical deep learning setup, a convolutional neural network, would have multiple layers. But for our discussion per se here, we can talk about the convolutional layers and fully connected layers. So the amount of data processing that is needed here, there are different things, different characteristics of these data processing in different layers. So for a convolutional layer, they are typically extremely computation complex. So there is a lot of calculations that you need to be doing. Whereas the fully connected layers are much more complex in terms of memory access, meaning they need to access external memories much more frequently, and well, many more number of times. So when we use a Microsemi's FPGA, what you find is that we have something called our math block, which has the dot product matrix computation, which can do two multiplications and an addition in a single cycle, which is not available in any other microprocessor, in any other FPGA portfolio. This is one key advantage from Microsemi. So in essence, what you can get is a much more capable FPGA, which is much faster, as well as low power. So this is a typical, this is a comparison that we've done on a tiny YOLO sample. So we were able to achieve almost double the performance at half the power. So this is what we've implemented on the PolarFire FPGA from Microsemi. Another part is that this particular deep learning algorithm is actually from one of our partners called ASIC Design Services. And the solution that they have is extremely scalable. So what you can do is, based on the FPGA you select and what kind of power elements you have available in your system, and you can decide what is the size of the solution you need. So for example, you have variables on wattage, how much of power available, the frame rate, and how much number of logic elements you want to use the FPGA. So you can tweak based on your specific requirement, and you can design your own deep learning system using our FPGAs. So yeah, pretty much to summarize, we have higher processing power due to an efficient math block. So we are able to achieve much lower performance and deliver higher performance. And it is an extremely scalable design that you can quickly modify and work with us and come up with your own deep learning algorithm. So this is a demo we have done. I'm not sure if this would work. Let me. Oops. So just give me a moment, please. I was expecting that. So this is a video of the deep learning demo that we were able to achieve. This is one of our engineers who. Yep. So that's pretty much what I have. Thank you for your time.